Hello everybody. Let us try to solve a problem from the branch of number theory. Credits to the Art of Problem Solving community for providing me with this item. The problem goes like this. Find the smallest integer x for which square root of x plus square root of x plus 2005 is an integer. Let's dive in with the solution. For the given expression to be an integer, x and x plus 2005 must be perfect squares. If they are not perfect squares, then the sum wouldn't be an integer. Although it is not impossible for two irrational numbers to add up to an integer, since we're taking the principal square roots of x and x plus 2005, there is no way for them to add up to an integer if not both x and x plus 2005 are perfect squares. Therefore, we must have x and x plus 2005 be perfect squares. Let's have the substitution m squared equals x and n squared equals x plus 2005 to represent the two perfect squares that x and x plus 2005 represent. In this case, it is safe to assume that m and n are greater than or equal to 0, since we are only dealing with the principal square roots. From this, we can take the difference n squared minus m squared, and that will be equal to 2005. Now, since m and n are integers, since they are perfect squares, we can use the concept of factoring. Now we can factor the left-hand side of the expression since it is a difference of two squares. We can factor it into n minus m times n plus m, and then the right side we can prime factorize 2005. Note that 401 is prime, therefore the prime factorization of 2005 is 401 times 5. There are numerous ways to find how 401 is prime, the most famous one being the sieve of Eratosthenes. So you can look up on that and study, just in case you are unfamiliar with the topic. Now from this, it is a matter of listing cases. In fact, there are only two ways for two integer numbers to have a product of 2005. Since n and m are integers, their sum and difference will also be integers. Note that there are only two ways, 1 times 2005, which is equal to 5 times 401, and that's how you make a product of 2005. And now we assign these factors to the factors on the left-hand side of the given equation. Let's take the first case, 1 times 2005. Obviously, n minus m would be the smaller factor, and n plus m will be the greater factor. Therefore, we assign n minus m to be 1 and n plus m to be 2005. This gives us a solution, n equals 1003 and m equals 1002. Now for the second case, 5 times 401, we assign 5 to n minus m, and we assign 401 to n plus m. This gives us a solution, n equals 203 and m equals 198. Since we're asked to find the smallest integer x, we should take the smaller value of m, since we had the representation m squared equals x. Therefore, we substitute m equals 198 to the equation. This gives us that x equals 198 squared, and then evaluating that, we're going to get 39,204. And this will be our final answer.